Okay, so 5.2 day 2, we're going to complete our trig integrals. So just take a minute and fill these out. Antiderivative of cosine is positive sine of u plus c. This is tan of u plus c. Secant of u plus c. Negative cosine of u plus c. Negative cotan of u plus c. And then negative cosecant of u plus c. And then what we talked about yesterday, our log rule. This is the natural log of the absolute value of u plus c. Okay, so let's look at the antiderivative of the tangent of x. So I'm going to rewrite this as sine of x over cosine of x dx. Now I'm going to make a u substitution. I'm going to pick the denominator, which makes du negative sine of x dx. So we have sine of x over u times du over negative sine of x. The negative comes out front, and now I'm integrating in the form 1 over u. So negative ln absolute value of u. So negative ln absolute value of cosine of x plus c. So what's the antiderivative of tan of u du? Negative ln absolute value of cosine of u plus c. Using the same reasoning, we'll rewrite cotangent as cosine of x divided by sine of x. Selecting sine for u makes du cosine of x. So we have cosine of x over u times du over cosine of x. So now we're just integrating positive 1 over u. So that gives us natural log absolute value of u. So natural log absolute value of sine of x plus c. So our integral rule, ln absolute value sine of u plus c. So now these are two rules that you just have to be able to use, just like these antiderivatives of the 6 other trig functions we learned, okay? Now, it's an easy enough method to set up a u substitution if you do in fact forget what the antiderivative of tangent or cotangent is, but you are expected to use it whenever if a problem needs it. Now we will talk about where these answers come from, but jot these down for me. Antiderivative of secant is the natural log of the absolute value secant of u plus tan of u plus c, because it's indefinite. And the antiderivative of cosecant of x dx is negative ln cosecant, let's make these u's. So negative ln cosecant of u plus cotangent of u plus c. Okay, so in addition to tangent and cotangent, these complete all of our trig antiderivatives. Okay, so let's use them with problems. Oh, so in addition to power, u substitution, log, and trig, we have these 4 new antiderivatives. Okay, so tangent of 5 theta, look at theta. It has a derivative that isn't 1, so we do need a u substitution here. We'll pick 5 theta, which makes du 5 d theta. So my u substitution becomes tan of u times du divided by 5. Bring the 1/5 out front times the integral of tangent of u. And the antiderivative of tangent, negative ln absolute value of cosine of u. So just cleaning this up and replacing u with 5 theta plus c. Okay, antiderivative of 2 minus secant of x over 2. So let's look at this as two separate integrals. The antiderivative of 2 is just 2x. Now with the secant, using the same reasoning as the problem we just did, we do need a u substitution here. So 2 du is what I will replace dx with. So secant of u times 2 du. So the 2 comes out front. And now the antiderivative of the secant function, and this is where you'll get better with this as you practice, ln absolute value secant of u plus tan of u. So now just replacing u with x over 2, and then plus c. Okay, so we can use this with definite integrals as well. The antiderivative of cosecant of x is negative ln absolute value cosecant of x plus cotangent of x, minus the antiderivative of sine is negative cosine of x. We evaluate that from pi over 4 to pi over 2. So negative ln absolute value cosine of pi over 2 plus cotangent of pi over 2 plus cosine of pi over 2. Alright, so this is just plugging pi over 2 into the entire function. We'll do this in pieces. Cosecant of pi over 2. Cosecant is 1 over the sine, so that's 1. The cotangent would be 0. Cosine of pi over 2 is 0. So negative ln of 1. That evaluates to 0. Okay, now plugging in pi over 4. Negative ln cosecant of pi over 4 plus cotangent of pi over 4 plus cosine of pi over 4. So this would give me cosecant's 1 over sine, so 2 over square root of 2. That would be 1. Cosine of pi over 4 is square root of 2 over 2. So we have negative ln absolute value of this plus square root of 2 over 2. Now, the fundamental theorem says we take big F of pi over 2 and subtract big F of pi over 4. So 0 minus this will just make our answer positive. Now, this is a number, and it's a positive number. So we can write that 2 plus square root of 2 over 2, and then plus square root of 2 over 2. Sorry, that should be a square root of 2. So that would be our final answer. Okay, so looking at this, we have two possibilities for a u substitution. If you pick cosecant of t, because that's an inside function, it's inside the squaring function, the derivative is negative cosecant cotangent dt. So think about what we talked about before your quiz. If I took that out as u, I don't have enough in my integrand to make that the u substitution. So now that we have the log rule, let's pick u to be the denominator. So cotan of t, the derivative is negative cosecant squared of t. So this would be cosecant squared of t over u times du. These cancel, and we get negative integral of 1 over u du. Negative ln, absolute value of u, so negative ln, absolute value. Cotangent of t plus c. Okay, last example, solve the differential equation. So let's separate r on the left, multiply both sides by dt. Again, what's the significance of the point? This will be our particular solution. Integrate both sides. Antiderivative of dr is r. Now over here, again, think about what the derivative of secant is if you wanted to pick u to be secant. It's secant t, tan of t. There's not enough in the integral to make that to make that cancel. So let's choose u to be the entire denominator. Derivative of tangent is secant squared of t. Derivative of 1 is 0. So du all over secant squared of t. These cancel nicely, and now we'll just use the log rule to integrate this. R equals ln absolute value of u plus c. So we have ln absolute value of tan t plus 1 plus c. Now let's plug in our point. R is 4 when t is pi. So tan of pi is 0. 4 equals ln of 1 plus c. ln of 1 is 0. So 4 is equal to c. So our final answer for this, r equals ln absolute value tan t plus 1 plus 4. Okay, so a few homework problems to attempt. They are odd, so you can check your answers on CalChat, and I'll see you next class.